Welcome. In this lesson, we are going to look at cross validation, and we've gotten to the part of the course where we start to think about how to make our model better. So, in the previous classes, we are looking at how to actually train these models, the idea behind all of the algorithms that we are using to train these classical machine learning models, and we one thing is there are a lot of factors that contribute to just how good your final model is going to be. So one of them, and the most important one of them, is the data. So right, so um, some factors that contribute to how good your final model is going to be. The first one is the data that you have. The second thing is the model hyperparameters. And what does that mean? That's actually what we are going to like be getting into in the next class. Well, it means, let's say we take random forest, an algorithm like random forest. Random forest has hyperparameters too, right? So some parameters that goes into the algorithm itself, and those things can actually impact the outcome of our model, of the training rather. So you can think of it as extra decisions that we are making. Decisions like, okay, for random forest, what is our n estimator? What n estimator value are we choosing? you know what an estimator value are we choosing, what um max depth are we choosing, what criterion are we using, things like that. An estimator meaning what no how many trees are we building for this particular model. Max depth, how deep are these trees going to be, each of these trees that we are training, how deep are they going to be. Then criterion, what is the criterion that we're going to be using? Is it Guinea? Is it entropy? Is it, all of those stuff like that? But all of these ones, they are called hyperparameter tuning or optimization. But before we get there, there is the data aspect. There is the data aspect of making our model better. And the first one is, nothing beats getting more data, right? Getting more data, nothing beats that. But it can be expensive in real life. It can be very, very expensive. And sometimes you are just constrained within this very within the available data, and that's all you have to work with. And that's what brings us to data cleaning, right? So you clean your data properly, just data wrangling, you visualize, you test hypothesis, you understand the in and out of your data, so you know what works and what won't work. And another important thing is actually the data split, right? And um that is what um cross validation attempts to fix. So how can data split be a problem, right? How can data split be a problem? Now imagine we have this data. Imagine we have the data of x1. Let's just say x and y. X and y. We have a data of x and y, and it goes like 1, 2, 3, 4, 5, 7, 15, and 20 maybe. And this is 0, 1, 2, 3, 1, then 14. Let's call this one 15, 12, 19. Now if you look at this data set, you're going to see that in this data set, the first, I'm coming, let's count 1, 2, 3, 4, 5, 6, 7, 8. Let's add two more. Let's just add 18. Let's say maybe that is 35, and 17, and that is 29. So I'm going to change this ones from here all the way to this place. I'm going to change it to some small values just to make our explanation better. 6, 4, and I'm going to make this one 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is fine. This is fine. Now, so look at what we are doing. So let's say we train with this. If we want to train a model with this particular data that we are looking at. What we do is we are going to use train test split. So we make our we are going to have our x train and our x test. So we should split now. What we are going to have is we are going to have something like all of this from here. So if we are doing, let's say 70-30 split, so all of this from here like this, they are going to be x train, x train, and all of this is going to be our y train. Then all of this is going to be our x test, and this is going to be our y test. Now, what's the problem with this? Even merely looking at it yourself, you see that there's a problem. The problem is that for all of the things that we train with here, they are usually very small values, right? They are very, very small values. Uh, Outputting small values also. If you want to train, we do something like model dot fit, and what are we fitting on? We're going to fit on x train, y train. I hope you haven't forgotten that. Now, what we are fitting on x train, this, y train, this. Meaning the actual large values, the large kind of things that's going to happen, our model did not even see it during training. Is that right? So imagine we train with something that looks like this, and we are testing with something that looks like this. It might cause the model to drop in performance. And if we, let's say this is model one, let's say this particular model is model one, then we have another model where we just randomly select and all of these big values fall into train and the small value fall outside of train. We are still going to have another different model performance, right? So what cross validation attempts to solve is what we are seeing right now. So instead of just looking at train test split and we are looking at just one kind of split, our model performance on one kind of split, what we can actually do is do several splits, like several splits, and see how our model perform on each of these splits. Then we can also average it out. We can average out all of these results and make it. So let's say your model is this. Let's say you have one model like so. I say model. Let's say you have one data like this. Uh, one data like this. So this is your old data, like this logs into your old data. So instead of just doing one train test split where all of this is going to be train, let's call it extrain, let's just call it train. All of this is train, and all of this is test. Instead of doing that, what we are going to do is we are going to split it into something called number of splits. Let's say our number of splits, let's say number of splits. Let's say that equals 5. That means we are going to split this thing into 5 equal parts. 1, 2, 3. Then we can do 4. Yeah. So 1, 2, 3, 4, then 5. So we have 1, 2, 3, 4, and 5. So what we do is I'm going to call, so let's assume red means train and green means test. So this is going to be train, 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 and this is going to be test, right? So we call small letter t, let's call it test. So what do we do again? We are going to, let me just control CV this. Now we are going to have another split where all of this is now going to be, let me do this, excuse me. where this is now going to be, let me, please give me a minute. Perfect. So this also is going to be train. Now let's turn that to red. This also is going to be train. This is going to be train. But this is not this one here is not going to be test anymore because that's what we used for test earlier. So we are going to remove that, remove this also. So this is also going to be train and the test is now going to be this. So now imagine we are doing it for 5. So for the first one, we have train with this, train with this, train with this, train with this. That is all of this. It's going to be our training set. Then we test with this. Then we record the model performance. Then again, we train with this. Then the last one also we train with it. And this also is now going to be our test. So then the next one you can imagine, we're going to train with then this. The one is going to be our test. Then the next one train with this. This one is going to be our test. Then last one, we're going to test with this, we train with the other ones. Then we can now average out. So by then, imagine if this is the data set, we would have used everything, every combination possibly as train and also as test, every combination of the split as both train and test. And that what we've just explained is the idea behind cross validation. So let's quickly code it. There are two things that help us to do cross validation. Number one is KFold within sklearn. Number one is KFold, and number two is StratifiedKFold. StratifiedKFold. So let's see how it works. So we'll come here and we are going to let's start with regression first. So we can say regression with KFold. So we're just going to import the things that we need. So I can say from, let's connect this. I can say from sklearn dot data sets. We're going to be using that data set from that data and diabetes data sets from sklearn. I can say from sklearn dot database data sets import load diabetes. Say from sklearn dot model selection. I'm going to import KFold. I'm say from sklearn dot assemble. We can just use decision trees. So I can say from sklearn dot trees, excuse me, dot tree, we'll import decision tree regressor. Then we can say from sklearn dot metrics, we're going to import root mean squared error. Perfect, perfect. I think that might be everything we need. And if we need more things, we are going to come here and add it. So let's get our data. I'm going to say data equals um, load underscore diabetes as frame equals true, and that's going to be our target, our data, sorry. And here is going to be data target. That's going to be load underscore diabetes for target. So if we do data dot add, so this is what we want to work with. We want to use all of these to predict all of this. So let me remove this target here like that. Great. So now, and I loaded it like this so that in the case that you're working with your own kind of data set, it's usually going to be pandas data frame. So it's going to be easy for you to replicate exactly what is inside this tutorial, this course. So the next thing we want to do is we want to split our data set into x and y. So you go x equals data dot drop I mean, I could have avoided this just by loading in that data set in a different way, but you're not going to get the luxury of that when you are working with your own data set. So that's why I'm structuring this like this, so that you can just absolutely follow the exact same thing that is in here. So we say target y equals target. So I can come here and run this again, then run this again. Perfect. So we split our data set, and the next thing that we do is we actually set up cross validation with KFold. So how do we do that? Step one is we are going to initialize our regressor. So how do we do that? You can say regressor, or you can call it estimator. So the thing that we want to use to actually train the algorithm that I want to use. In this case, is decision trees regressor, and the only thing that we are passing is random state equals 23, and let me see init the estimator. We're going to be initializing the estimator. Then the next thing that we want to initialize is the cross validator, what we want to actually use for cross validation. So we are going to say k underscore fold, which is what we want to use, is going to be equals to k fold like this, and number of splits like I showed you earlier. Number of splits I want to split it to, let's say 7. Then shuffle, I'm going to set shuffle equals true. I'm going to explain this shortly. And random state is going to be equals to 23, or any value that you want. Now, if you do shuffle equals true, you must set random state for your own good, so that you can always be able to reproduce all of the splits. But if you do shuffle equals false, you don't need random state. What does that mean? If you come to our board here, saying shuffle equals true is saying, let's say this is the data set. If you say shuffle equals true, it is not just going to split like this and split like this. It's going to like shuffle the whole thing. They can pick 1, 4, 15, 5, 3 into X string. But if you say shuffle equals false, it is going to always do it, index wise. That is, it's going to take the first um numbers, like in descending order, like sequentially like this. So it's not going to like randomly select all of those things. They are going to follow each other. And in that case, you don't need random state, because well, it is going to be the exact same way every time. So, but if you do shuffle equals true, you must set random state. If you do shuffle equals false and you still set random state, in the old sklearn, I don't know if they still have that implementation, you're going to get some error. So yeah, you're going to get errors. So it says setting a random state has no effect since shuffle equals false. So if you remove random state in that case and run it, that is going to work. But that is not what we want. So we always want randomness. Randomness is good. So we say random state equals 23. So if we still run this still works. Perfect. So the next thing we want to now do is we want to actually now, you know, do the split and train the model. We're going to do the split and train the model. So what we're going to do is we're going to loop over that split. We're going to say for train underscore index, comma test underscore index in KFold dot split x equals x, y equals y. You don't really need to do y for um KFold, but it does not ought to do it. So whenever KFold actually splits, it does not really split the entire data set. It just splits the index, because well, index is going to be associated with each row. For example, this row 1 could have index 1, index 2. So whenever I call on 1, I'm literally just calling on this entire thing. So there's really no point in carrying the entire data frame, right? There's really no point. So that's why it splits just index. So and that's what we are. So whenever we run kfold or split, we expect two things: the train index and the test index. So we are going to loop over that. Is that right? And it's kind of like a top of index. So we're going to loop over both and say our x train now, comma x test is going to be equals to x dot ilog. Ilog is how you reference index, how you select rows based on index. Train underscore index, comma x underscore test, and that's going to be um test underscore index. Then here y underscore train, comma y underscore test. That is going to be equals to y dot ilog train underscore index, y dot ilog test underscore index. Good. We've splitted and we've gotten our split. So the next thing to do is to say you're going to fit the model. There's a regressor dot fit x underscore train, comma y underscore train. Next thing is to get predictions. So I'm going to say train pred. That's going to be equals to regressor dot predict x train, and the other one is going to be test pred, and it is going to be regressor dot predict x test. Now we can proceed to evaluate the model performance for each split. Now do we do that? We're going to say train RMSE is going to be root mean squared error of y train, comma train pred, and the second one is going to be test RMSE, which is going to be root mean squared error of y test, comma test pred. And here we just need to print out outcome now. So we can say split. Okay, we need to let's just be counting this the split from outside there. So I'm going to set split equals, let's say split number, let's call this one split number, and that's going to be 1. So I'm going to say split of split number, and here we're going to say train RMSE is going to be some value, and test RMSE is also going to be some value here. Great, great, great. So the only other thing we need to do is to increment split so that everything will not come out as split number 1 plus equals 1. Great. So if we run this and see there's no error, we have an error. It says name x test is not defined. So we'll come to this place. Really? On what line? Oh, yeah. That should not be x test, should just be x. Yeah, that's perfect. So we'll run that again, and another error. It says number of index are in the columns. So let's go check what the problem is. For which line? This x dot ilog. Okay. So we say for train index text index in KFold dot split x equals x train, comma x test. Have we splitted our data set? I think we have. For let's just rerun this, and regressor equals this, Yeah, that's cool. For train index in KFold or split, X train, X dot I log, train index, test index, Y train index. Now that looks good to me. Let's give it one run, see if we still have that problem. Then in the columns, none of index 14, 18 are in the columns. So let's check. Let's start by checking X. Okay, 442 rows. That looks correct. I'm guessing. Let's take out this Y firstly. Training index, testing this. Okay, let's play. Okay, let's. The same problem. I That's probably going to be something very, very. I'm missing out something. Oh, dot ilog. This is a non-pi representation. So this should be dot ilog train underscore index. Test underscore index actually. Right. So if we return y equals yn, that should still work. So let's run that and see. Yeah, so it's working now and it has trained. Wow. Wow. That is very, very interesting in that it completely overfitted, like performed terribly on the test set, terribly. But well, where we're actually going is we see that the test RMSE got as low as 71 and got as high, as bad as 90. So that is what this thing shows us. And if we want to actually see the true power of the model, like how the model is performing, we just need to average this. So how do we do that? We can do that by actually tracking. We can come here and say train score, comma test score equals, comma, yeah, perfect. So after doing this, all we have to do is just say train underscore score dot append train RMSC test underscore score dot append test RMSC. So we can come outside of the loop anytime the loop is done and just print f string overall train score, and that's going to be sum train score all over len of train score, and the other one is going to be overall test is going to be equals to uh, sum test score divided by len test score, or you could just put this in a numpy and call dot mean on it, anyone that works for you. So if we run that again, we get this value. So it says overall train score is actually point 0, like there's no, the train RMS is just 0. It's overfitting a lot. And the test RMS is um 82.841. So that is how you do cross validation with KFold. And you can also use KFold for classification problems. But the best one to actually use for classification problems is KFold. Stratified KFold. It is not just ordinary KFold, stratified KFold. So how does that work? Let's actually see that with a classification problem. So I'm just going to copy. It's going to be a lot of copying and pasting because the code is very very close. It's almost the same thing. Just come here and say classification with KFold with stratified KFold. Stratified. Yeah. Excuse me. Great. So let's just go up here, copy. I mean, we have majority of the things here, but I'm just pretending like we are just doing this from scratch. So you don't. We are not going to be using diabetes data set. It's going to be the breast cancer data set because that's the classification data set. And for model selection, we're going to be using stratified KFold. And for the estimator, that is going to be decision tree classifier. And our metrics is going to be F1 score. F1 score. Right, we run that, and next thing to do is to load in the data set. So we paste that here, and that is going to be the load breast cancer dataset. Control D, and then we load underscore breast cancer dataset. We run that, and that's going to be this data that you see here, and we're trying to predict this target here. Then the next thing is we split Control A like this and paste that here. So it's almost the same flow, but the main edit, like the main difference, is going to be from this place. So firstly, our stuff here is the classifier, right? So the classifier classifier is going to be equals to decision tree classifier. Then this KFold is not just going to be KFold, it's going to be stratified KFold. So let's say st underscore KFold like this. Then here is not going to be KFold, it's going to be stratified KFold, right? Other things, it takes the same parameters as this one. But in the case of stratified KFold, you must pass in, I told you earlier that you could leave this open and you could remove y here and KFold is still going to work. Well, in the case of stratified KFold, and stratified KFold does almost exactly the same thing that train test split does with stratify equals y. So we just want to do KFold, but with respect to the distribution of the categorical variables, um, um, with respect to the distribution of the groups inside our y, we want to make sure that when we are splitting, we pay attention to our y, right? So we see that there are zeros are lesser than ones that we have. So want to pay attention to it. So that is the reason why you must pass in your y. So with that done, everything else is fine. So the only other thing to do here is just say classifier. Okay, let me actually do Control Z Z Z. So I'm going to turn all of this regressor to classifier. Classifier.fit, classifier.predict. Then all of these root mean squared error, they are going to become F1 score. And all of these RMSE are going to become train F1. It's become train F1. F1. Perfect. Train F1, test F1, everything looks good. So, that is just there is really no difference. So we run this now. It has worked. We see the performance of the train set overfitted again. Everything is perfect on the train set. Then on the test set, is great too, right? But can be better. So 0.95 got as bad as 0.93 and got as good as 0.97. Just look at that difference. Just based off how we split our data alone, we have that magnitude of difference. So that is stratified KFold. And in some cases, if you don't want to go through this very long But it's not long really. If you want to go through this manual way of doing KFold by or of doing cross validation by yourself, there's actually something from sklearn called cross val score. So you can say from sklearn dot model selection import cross val score, which is like an automatic way, but it limits you a lot because you don't get to do you cannot customize it as much. So cross val score, the first thing you pass in is your estimator, which is going to be your classifier in this case, like the model that you've initialized. Then your x is going to be your x, your y is going to be your y, and your scoring, in this case, our scoring is going to be F1, and you don't need to like worry much about it. You can put anything there, it's going to throw an error and tell you what to use because they are not usually the same name as the metrics that you are already familiar with. Then CV is going to be the number of folds that you want. So I say CV equals 7. Then end jobs is, do you want to train in parallel or you want to train sequentially? So one for parallel, negative one for parallel, one for sequentially. Then verbose, so the level of output that you want, how detailed you want the output to be, starts from 1, stops at 3. So 3 is going to be very expressive. And the last thing that express really is just the test score. I feel like that's everything. So if I should run this now, so can you see it's training in parallel now? So it just returns our output. And like I said earlier, this actually limits what you can do. It just returns the test set for you. So the opportunity for getting trained and all of that is not there. And also, you still have to compute the overall mean. So he's saying for all of your uh, 7 split, this is for score 1, 2, 3, 4, 5, 6, and 7. So let's say I put this, I told you earlier that -1 is parallel. So 1 is going to be, sequential. Can you see? Train the first one, train the second one, third, fourth one, fifth, like that. And it returns the outcome for us. So, yeah, that is that. And if you reduce or increase verbose, you get different output. So let's say I want to now get the overall score. Don't forget, like I said earlier, this is the test score. It is only returning test score. So I can say score dot mean because it returns a numpy array. If I run that, so I see that the very thing is 0.9389. Right. So, but our own here we got 0.9487 because of the split. Another thing that you can do is you can really pass KFold here. So, for example, I can say CV equals st.kfold dot split, and I can go x equals x, y equals y. So instead of just passing 7, I can do my fold myself. So that way, now we have the same value that we had up here when we did it manually by ourselves. So that is how you will do KFold again, cross validation. And the idea behind cross validation is the opportunity for us to be able to see how our model performs on different kind of splits of the data set. So thank you very much for being a part of this class. I'm going to see you in the next one.